So the next few slides, I won't detail to talk about that because all the information I already explained in the previous video about how to create the object using the new keyword. So I want you to, instead, I will explain line by line to you. I want you to make sure you read through that to see if you have any question, then we can talk about in the Zoom meeting or in the discussion. So you will see how you were using the new operator to call the constructor function. So then after you create an object, you see here when you want to create an object, so the first thing you need to have your class name and object reference variable. So for example, earlier we have the circle C1. So that's the object reference variable name. So after you create this variable reference name, you can right away using the equal sign to assign the new keyword with the constructor function to have this variable to refer to the object. So what I want you to see more clear is, even you sometimes using the my reference name equal to new keyword, right? So then here afterward, what we create, after you have your object reference variable name assigned to the object, then you can using this name dot, using associate with the dot operator to call all the data field. Like earlier, you see we have the C1 dot radius, we have the C1 dot get main method. So that's the object member you can refer by the data field and the method using the object reference variable name and with the dot operator. So that's we all talked about in the previous video. So the most important thing, I just want to make sure you read through line by line to make sure you understand that. So the most important thing I want you to know is this picture. So did you remember earlier we created the C1 and the C2 object? So we have the C1 object, we're using the default constructor. So supposedly if default constructor radius is 1, but here we just say, for example, we change become 5. Then you have C2, the same thing, you knew another circle object. So then you refer to that. So actually in the memory location, that's how the object and the object variable reference look like. This C1, C2, they are just a variable. Then they are using refer to the object itself. And also when you create two circle object, I want you to see these two circle object actually they only contain their data field. So that's the unique attribute to identify this circle. So then you see you have C1, C2, right? But then afterward, if you try to using C1 equal to C2, what will happen? You need to be careful. C1, C2, they are object reference variable. So if you try to assign C1 equal to C2, that means this reference will refer to where the object C2 refer to. So that's why afterward they will look like this. And you can see after this one, right? This circle object earlier C1 referred to is no longer accessible. So that's why now if you try to using the C1 dot C dot radius, they will become 9. So they will all refer to the same object. Also, I just want to explain this one because that's very important when you using the Java program to create any object, to declare any object reference. That's how the memory look like. So you can assign C1 equal to C2, and you also can compare C1 equal to C2. So in Java, if C1 equal to C2, they return true. That means they both refer to the same object. Because when we try to compare C1 and C2, we have the memory location saved in C1, C2. So when C1 really equal to C2, that means they contain the same memory location. They refer to the same object. So that's the same mean. So that's why sometimes when we have two strings, you need to be careful. When we want to compare two strings, anytime when you want to using the object reference variable equal to compare, are they equal to the other object reference variable? Actually, you try to compare is, are they refer to the same object? Okay. So sometimes this one, the equal operator check only whether string 1 and string 2 refer to the same object. So the same object, you need to be careful. That really means they are the same object, single object. But sometimes remember string, different object, they have the same content as well. So that's why sometimes you really need to know when you want to compare C1, string 1 and string 2. Are you trying to compare what? If you only care is the string content, these two content are the same or not, please do not using the equal. Because equal, they are referred to the exactly the same object. So sometimes if we only want to compare string 1 and string 2, they have the same contents or not. So then we're using the dot equals method. So the dot equals method also return true or false. But instead they check they are referred to the same object. They only check if they have the same content. So that's about the string comparison. So the same thing, I want you to read those slides by yourself. So then if you have any question, post in the discussion or we will discuss in the Zoom meeting. So after we talk about the object or string comparison, so the next one that's really talking about the static keyword. So now I want to talk about again the static keyword, and the other term is we call the instance. We have static method, static variable, and also we have the instance method and the instance variable. So here earlier our definition about the circle class, we define radius, we define the method. Okay, so in the UML diagram, all the data field and the method you define, if they don't have the static keyword, all those method or variable we call instance variable, we call instance method. So including the construction method, those things, they are all the instance method. So all the instance variable or instance method, they belong to object. That's why you can see after we define the circle class, I have 3 circle objects. So each circle object, you see, they have their instance variable belong to them. Yeah, instance variable radius belong to them. Good? Good. So after you understand that, so then we can really talk about what is the static keyword. So sometimes you have the instance variable that belong to the object. But sometimes we have some static variable actually is shared by all objects in the class. So that's why sometimes the static variable we are talking about, they are class variable. It's not object variable. Sometimes we can say static variable is shared by all objects of the class. Or sometimes we can simply say static variable actually belong to the class. So on the other hand, the same thing. A static method is belong to the all object of the class. And a static method cannot access instance member of the class. So if you want all the instance of a class share the same data, we're using the static variable. So the static variable, they will store the variable actually is not belong to the object. So that you can see in this one, you see, instance variable resides in the object itself. But if I define a static variable, they are not belong to the object, they were in the memory somewhere. For example, we just say circle. Did you remember earlier we had pi? Pi is equal to 3.14159. So pi actually is not belong to any circle. They are belong to a universal. Yeah, so any circle using the pi, they're using the same pi. So that's why you see, remember our pi, right? Since our pi actually we already defined in the math class. So that's why you see pi actually is a static variable belong to the math class. And also, like we say, when you have the static method using the class name, then method name to invoke. So if you have static variable, you're using the class name dot the variable name to access. So that's we call the static variable. Static variable is known as a class variable. Static variable stored in the common memory location. So because that common memory location, so if an object try to change the value of a static variable, yeah, the object actually can change the static variable unless we make that private. So then all the objects of the same class, they are being affected. So then you see you have the static variable, you have static method. The same thing, static variable and the static method, they don't need to be called when you have any object create. Actually, static method can be called without creating any instance of a class. So this one, the instance of a class mean object. So instance of class mean object. So the static method doesn't need to have any object created. So did you remember, you see like your math.random, your math.pi, they all are static variable or static method. So they don't need to wait until any object create, they can be invoked. So that's why we will see a static variable example. Let's modify the circle class. We add a static variable called number of objects. We keep checking how many objects being created. Then we have static method get number of objects to count the number of circles being created. So then see here, that's our updated UML diagram. You have the class name, you have the data field, its radius. So if you have any data field, they are static variable or static method, you see we add underline. So then we know the number of objects is the static variable. So then the next question is, how should I define the static variable? So let's see here. Also, that's how we define the static variable or static method. You just need to add static keyword before that. So did you see this one? It's very familiar. Did you see your main method, you have static keyword, right? So any attribute or method, if you add the static keyword, so that's how they will become. As we have our complete new circle class, we call circle with the static member. So you will see we still have radius, but now here we add a static variable we call number of objects. So this static variable will keep counting. We give them the initial value equal to 1. So in any constructor, I add, if constructor function being called, right, I increment the number of objects by 1. So then you see they need to be in both constructor function. So then I have the static method, I return number of objects. So this one we will using another main function to test. So this one is the circle with static method. So then we have the test circle with static member. So I want you to run this program and to see if you understand. So you can see here, we print before that, before we create any object, how many static member from object we have. So then we can create C1 and can create C2. So then we can change the radius. So then if you run the result, I want you to check this program. So you see you run the result. So that's why we see we have